Hello everyone and welcome again to my How To Education channel. As I promised you last week, today we're gonna continue with How to Ace Economics, Working with Elasticity Part 2. After watching this video, don't forget to leave me your feedback. After defining the elasticity concept and going over the types of elasticity last week, we will now speak about the extreme cases of elasticity. The extreme cases of elasticity can be divided into two types. Number one, elasticity is equal to 0, and number two, elasticity is infinite. Let's take a look at each case now, and a look at the demand or supply graph for each case. We will finalize this chapter by taking a look at the elasticities other than price. We previously defined price elasticity as the change in quantity with respect to a change in price. Now, let us go over the extreme case of infinite elasticity. Infinite elasticity is also called perfect elasticity and refers to an infinite change in quantity demanded or quantity supplied with no change in price, and to an also infinite change in quantity demanded or quantity supplied due to any change in price, no matter how big or how small. The graph of a perfectly elastic demand curve or a perfectly elastic supply curve is a horizontal line. This perfectly elastic demand graph shows how quantity demanded is increasing indefinitely while the price is staying the same. A mere increase in the price will drop the quantity demanded to 0. This perfectly elastic supply graph shows how the quantity supplied is increasing while the price stays the same. A mere decrease in price from P1 to P2, for example, drops the quantity supplied to 0. It is hard to find real-life examples of an infinite, perfect elastic demand or supply, since this is an unrealistic situation. Nevertheless, a very close example of infinite or perfect elastic demand is that of two vending machines put next to each other. Just as the machines are installed and begin to function, their demand starts from 0 and continues increasing indefinitely at a constant price. If the price of one of them increases, the demand directly drops to 0, since customers will buy from the other vending machine. A very close example of an infinite or perfect elastic supply is that of a home baking business. Let's say that the owner of this business sells muffins for $2 per unit. The supply increases with time while the price stays $2 per unit. If the price goes below $2, you decide that it's not profitable to supply anything. If the price goes above $2, you're going to increase production by an infinite amount. Another extreme elasticity case is that of a zero elasticity. Zero elasticity is also called perfect inelasticity. It refers to a zero change in quantity demanded or quantity supplied, no matter how small or how big the change in price is. The graph of a perfectly inelastic demand curve or a perfectly inelastic supply curve is a vertical line. This perfectly inelastic demand graph shows how the quantity demanded stays the same while the price keeps rising. This perfectly inelastic supply graph shows how the quantity supplied stays the same while the price keeps rising. A very close example of zero or perfect inelastic demand is that of water. No matter how much the price increases, people will still need to buy the same quantity of water as it is vital for survival. A very close example of a zero or perfect inelastic supply is that of a very rare painting. That is, since it is a very rare painting, the quantity supplied will stay the same, but price tends to keep increasing, since you might not find this painting elsewhere. Before defining the price elasticity of demand or of supply, we actually define the concept of elasticity by itself. This is because the concept of elasticity does not apply only to price, and there are other elasticities as well. We will talk about the following elasticities now: income elasticity of demand, cross-price elasticity of demand, wage elasticity of labor supply, and wage elasticity of labor demand, interest rate elasticity of savings, and interest rate elasticity of borrowing. We defined elasticity as the concept used to verify if a change in a certain variable x will cause a higher, lower, or same amount change in a variable y, and price elasticity as the concept used to verify if a change in price will cause a higher, lower, or same amount change in quantities demanded and supplied. That is, price elasticity equals percentage change in quantity over percentage change in price. Thus, it is only logical to guess what the income elasticity of demand will be. Income elasticity of demand equals to the percentage change in quantity demanded over the percentage change in income. According to the midpoint formula, income elasticity of demand equals to the new quantity demanded minus the old quantity demanded divided by half the sum of both quantities demanded over the new income minus the old income divided by half the sum of both incomes. In the case of a normal good, income elasticity of demand is positive, since an increase in income will cause an increase in the quantity demanded of a normal good, and vice versa. Nevertheless, in the case of an inferior good, income elasticity of demand is negative, since an increase in income will cause a decrease in the quantity demanded of an inferior good, and vice versa. The cross-price elasticity of demand is equal to the percentage change in quantity of good A over the percentage change in price of good B. According to the midpoint formula, cross-price elasticity of demand equals to the new quantity demanded of good A minus the old quantity demanded of good A divided by half the sum of both quantities demanded of good A over the new price of good B minus the old price of good B divided by half the sum of both prices of good B. The cross-price elasticity of demand measures the percentage change in quantity demanded of a product when the price of another product changes. If this other product is a substitute, then when the price of this good, let's say good B, changes, quantity demanded of this good will change by the opposite direction. Thus, demand of good A will follow the same direction as the change in price of good B, as in they both increase or they both decrease. This implies that the cross-price elasticity of demand for a substitute is positive. If this other product is a complement, then when the price of this good, let's say good B, changes, quantity demanded of this good will change by the opposite direction. Thus, demand of good A will follow the same direction as quantity demanded of good B, and the opposite direction as price of B. This implies that the cross-price elasticity of demand for a complement is negative. The wage elasticity of labor supply is equal to the percentage change in quantity of labor supplied over the percentage change in wage. According to the midpoint formula, wage elasticity of labor supply is equal to the new quantity of labor supplied minus the old quantity of labor supplied divided by half the sum of both quantities of labor supplied over the new wage minus the old wage divided by half the sum of both wages. This measures the percentage change in the amount of workers willing to work once the wages change. It is positive since the quantity of labor supplied and wage change in the same direction. The wage elasticity of labor demand equals to the percentage change in quantity of labor demanded over the percentage change in wage. According to the midpoint formula, wage elasticity of labor demand equals to the new quantity of labor demanded minus the old quantity of labor demanded divided by half the sum of both quantities of labor demanded over the new wage minus the old wage divided by half the sum of both wages. This measures the percentage change in the amount of workers that firms are willing to have when the wages change. It is negative since the quantity of labor demanded and wage change in opposite directions. Interest rate elasticity of savings equals to the percentage change in the amount of financial savings over the percentage change in interest rate. According to the midpoint formula, interest rate elasticity of savings equals to the new amount saved minus the previous amount saved divided by half the sum of both amounts saved over the new interest rate minus the old interest rate divided by half the sum of both interest rates. This measures the percentage change in the amount of savings once the interest rate changes. It is positive since once interest rate rises, you will receive more money and increase your savings. Once interest rate falls, you will receive less money and decrease your savings. The interest rate elasticity of borrowing is equal to the percentage change in the amount borrowed over the percentage change in interest rate. According to the midpoint formula, interest rate elasticity of borrowing is equal to the new quantity borrowed minus the previous quantity borrowed divided by half the sum of both quantities borrowed over the new interest rate minus the previous interest rate divided by half the sum of both interest rates. This measures the percentage change in the amount of borrowings once the interest rate changes. It is negative since once the interest rate rises, it will become more expensive to borrow and you will tend to borrow less. Once the interest rate falls, it will become cheaper to borrow and you will tend to borrow more. This is it from economics for this week. But if you have reached the end of this video, it is because the content was helpful to you somehow. If this is the case, don't forget to give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with the third part of this lecture next Wednesday, but before that, I will see you all on Friday with some new finance content. Thank you so much.